So let's talk a little bit about some applications of conversions. The first one I want to talk about is the area and volume conversions. And so to start, let's just take a simple rectangle and think about what we remember about calculating area. Now, you don't have to remember anything because this is actually provided for you in the formula sheet, but do you remember how you calculate the area for a rectangle?
Length times width.
Yeah. And I can use Excel to kind of illustrate the concept here. If this is 2 cells across the top, and across here, you've got 5 cells. And there is a way that I can orient this differently. Then 2 cells times 5 cells is 10 cells, basically, is what I've got here. And that's the concept of doing length times width, right? Is this idea that if you take how long something is by how wide something is, you find out how much is in the middle. And that's area. Now, one thing that my example doesn't really do well is talk about the units of area. When I have something which is, say, 3 inches by 6 inches, we know that we do 3 inches times 6 inches, which is 18. But the question is 18 what? What are we talking about when we're talking about area?
Square feet or square inches, rather.
Square inches, right? And there's 2 ways you can write square inches. You can write it out like that, or you can write it in exponential notation, which is inches to the 2nd power. So remember that inches times inches is inches to the 2nd. Inches times inches times inches is inches to the 3rd power. These are the 2 that we're going to be talking about in this little section: square inches, cubic inches. And the word in front there is a sort of geometric representation of what I'm talking about. A square is, a shape where you have the same length and width. A cube is a 3-dimensional shape where you have the same length, width, and height. And that's really what a square inch and a cubic inch is it is a square that has one side is 1 inch and the other side is 1 inch. I like being in the physical classroom because in a lot of classrooms, the tiles are the standard 12-inch by 12-inch tiles. So they're 1 foot squared tiles. It's a good visual example of what a square inch and a square foot looks like. So you're going to do, typically what ends up happening is you are asked to do a couple of calculations using a formula and then compare things that have different units. And so I want to talk about the first part and then I want to talk about the second part. Now, again, in your formula sheet, this is where you're going to be looking because this is what you're provided when you're taking the test. So this is what you should be using when you're doing your homework. There's no quizzes in this section, so you don't have to worry about quizzes, but you should be using the homework and the review quiz as a way of kind of testing yourself and making sure that you understand how to do these types of problems. So when you get the test, you're not surprised. There's actually 4 things that they give you: area of a rectangle, area of a circle, volume of a cylinder, and then the volume of a rectangular box. So let's just take a more complicated situation. Area of a rectangle, I hope, is familiar to you, but let's talk about something like a cylinder. So if I'm looking at this shape, which is a regular can, now they tell you how much volume is in a can. You know that this is 12 ounces. I don't know if you can see my video or not, but in terms of doing this volume of a cylinder calculation, I would need to know how high this is, and I would need to know what the radius is. Now, in terms of the radius is from the center to the side. So when I think of a circle, there's 2 things that you usually talk about the radius and the diameter. The diameter is all the way across, and the radius is half of that, which is from the center to the side. So typical situation, let's do a cylinder example. I'll use this can. Wish I had a ruler right here. I'm going to use the can later. I'm going to actually try and measure that. I got to go find a ruler. So let's do rectangular box. And this is a real example from my life. A couple years ago, I had to do some concrete work, and basically I needed to estimate how much concrete I needed to do this pour, and it was the shape of a box. Sorry about that curve there. So you had something like 10 inches on this side. Say this part was 1 foot. And then this, oh Lord. Jeez. And then this length was like 28 feet. Okay, so I needed to figure out how much concrete I was going to need as a volume so that I could then do more math to figure out how many bags I needed to buy. Okay, so rectangular box, length times width times height, bada boom, bada bing. Go ahead and see what you get. Okay, did you get 280? Because if you did, I got you. It's not 280. What's the problem? Why is it not just 28 times 1 times 10?
You have to turn that inch into a feet.
You got mismatch of units because you got inches, you got feet, so you got to make a decision, right? I didn't tell you what to do, so you make your own decision. But either you need to do all inches or all feet, but you can't have a mixture. I mean, you can, but who wants to talk about feet squared inches? That's a terrible unit. I want to do feet cubed or I want to do inches cubed. So it's up to you how you decided to do it. Personally, I would do all inches just because that would be all whole numbers. So I would do like 28 times 12. That gives me my how long it is in inches. Then 12 inches on this 1 feet equals 12 inches. All right, and so in the end, if you did it in inches, you would have got 336 times 12 times 10. And that ends up being 40,320. And the units of that would be cubic inches.
A little confused. Could you do this again?
So basically, I needed to convert everything into inches or everything into feet. And what I'm showing you is everything into inches. So for instance, and this is where you're, now we're building off of what we just learned, right? So if I need to convert this into inches, I would do 28 feet over 1 times 1 foot on the bottom and 12 inches on top. And that's where I got the 28 times 12 part. Feet cross out, right? That's this part.
Okay.
I know 1 foot equals 12 inches, so I didn't really do a conversion there. I just sort of mentally replaced 1 foot with 12 inches. And the last one didn't need to change because it was already given to me in inches. So that's why I got the 336, and then I multiply by 12, and I multiply by 10.
Okay, I got it.
So the other thing would be, you know, 2 of them are already feet, so just change the 10 inches into feet and then multiply. You get a different answer, but you get an answer in feet cubed, which is fine. And actually probably preferable, because what ends up happening, or what ended up happening in this real life situation, was then I had to take my cubic feet and convert it into bags, because every bag is about 2.5 cubic feet of concrete, or makes about 2.5 cubic feet of concrete. And that's actually where we're headed, right? Is you're going to want to be able to convert something which is already in inches cubed into something which is in feet cubed. So let me show you that part. I guess I'll leave that stuff. No, I'm going to clear that. Okay, so you've got the drawing in your head or on paper or somewhere else. So let's continue this problem. Let's say we have 40,320 cubic inches of concrete. How many cubic feet is that? And then the final part of it, if there are 2.5 cubic feet per bag of concrete, how many bags would we need to buy? This is I mean, when I did this in real life, I was very excited because this is a real application of conversions where it really makes a difference, because going to Menards to buy concrete bags is not fun. You don't want to have to do it twice. So if you can do it once by buying the appropriate number of bags, then life is good. Okay. The reason this is complicated is because it's not just a 12-to-1 conversion. And that's the mistake that people most often make. I've got same process. I've got my 40,000 inches cubed. I've got my unit over 1 because it's not a dual level thing. I've just got a unit that I need to convert. And I'm going to convert this, and I am going to use the fact that there are 12 inches in a foot, but it's not enough to do it once. So I need inches on the bottom and I need feet on the top. But the key here is that that conversion actually needs to happen 3 times. So I'm going to do this once, I'm going to do it twice, and I'm going to do it 3 times. Why is it happening 3 times? Because what inches cubed means is that I've got inches times inches times inches. So in order to convert inches cubed into feet cubed, 3 inches have to be knocked out, not just 1. I know it only says it once, but you know, that's the point of an exponent. Inches cubed means inches, inches, inches. And they've got a good diagram of this on, I'll show you here in a second. I'll let you go ahead and do that calculation and do the conversion. And then those of you who did it in feet cubed will be able to see if you got the right answer. So across the top, it's going to be 40,320 times 1 times 1 times 1. That's a little silly because, of course, that's just 40,320. On the bottom, I'm going to have 12 times 12 times 12. And then I divide. Okay, so I get only about 23.3 cubic feet. On the bottom, I have 12 times 12 times 12. I have 3 factors of 12 because the inches is getting converted 3 times. That's the part where sometimes people struggle. Okay, then this last one is just a simple conversion, but it's not a conversion that you would be provided on the page. So this isn't a real test problem, but basically we set up the 23.3 feet to the third over 1, and I'm converting that into bags. So what are the units on the top? What are the units on the bottom?
One bag over 2.5 cubic feet.
Right. Put my feet cubed on the bottom, put my bags on the top, and that's correct that 1 bag is basically 2.5 cubic feet. So I'm going to end up dividing 23.33 by 2.5. So that's about 9-10 bags of concrete. Okay, of course I don't know whether you're ever going to be doing concrete work And maybe there's a tool out there that you can just plug stuff into and tell you how many bags to buy. But I was pretty excited about that. Doing some math in the real world. Okay, let's look at this can. So, because I want to do one with the pi symbol. I'm writing it out because it's harder to find it on the keyboard. The one for the volume is pi times r squared times the height. Okay, so what you need to be provided to do this is the radius and the height. Pi is just a number, it's a special number in geometry, which represents the ratio between circle's diameter and circumference. You don't need to know all that. It's about 3.14. I need to know this number to do this calculation, and I need to know this number. So I got my can here. My mom found me a meter stick. All right, this can is about 4 3/4 of an inch. This is the thing about inches. It always comes in fractions. Change that 3/4 to a decimal. 4 3/4 is the height. Okay, so height 4 3/4. All right, and the radius is from the center to the side. I'm going to say that's about 1.5. 1.5 inches. Okay, so to use the formula, first of all, go ahead and change these into decimals. Pi is about 3.14. You're welcome to use that representation. A lot of your calculators have a pi button on them. That's the symbol with the, looks like a table with one of the legs is kind of curly, like this. But you're welcome to just use 3.14. The only thing about the formula is that r has to be squared. So it's radius times the radius, 1.5 times 1.5, or you're welcome to use the exponent button or the square button. You probably have one of those on your calculator. Don't forget the units are a big part of this. So after you do all the number stuff, make sure you think about what are the units of this thing.
I got 33.58 inches cubed.
Okay, let's find out. So I'm going to do it with 3.14 first, and then I'm going to do it with pi, because Excel has a pi function. 1.5 times 1.5 times 4.75. Looks pretty good. A little bit different, right? A little bit smaller, but nothing to be worried about. Let's see if using pi gives me what Emily got. 1.5, I'm going to use the exponent button there. Yeah, so that gives me the rounded version of what she got. Okay, they both round to the 10th place. It's the same thing. So don't get totally hung up on where did I get the exact answer. There's some rounding going on here. That's just part of the process. And yes, it's inches cubed because I'm talking about volume. Sometimes people lose the cube and they think, oh, this is just squared, because they only see two things, the radius and the height. But remember, the radius is squared, so it's inches times inches times inches. Radius times height. Okay, cubic inches. Now, just for fun, let's go ahead and convert. Do you know how many milliliters are in a can off the top of your head? You can drinkers? Well, someone's got a can in their house. Let's convert inches cubed to centimeters cubed. Now, you've got the inches cubed, so you're going to set up a conversion, but remember, because it's cubed, you got to do that conversion how many times?
3.
3 times. What's the conversion factor that I need 3 times?
2.54 centimeters squared over 1 inch squared.
Well,
Or
it's not squared. It's just
or-
regular centimeters, regular inches, but I'm going to do it 3 times.
Oh, so that makes it cubed.
Right. The doing it 3 times takes care of the fact that I have inches, inches, inches over here. Turns it into centimeters, centimeters, centimeters. So this looks like it'll end up as 35.58 times 2.54 times 2.54 times 2.54. About 583. Sometimes people get confused with the notation of the cubed, and the 35.58 becomes cubed. That's not what we're saying. It's 25.58 of these things called inches cubed, which is like a cube that's 1 inch by 1 inch. Okay, did anybody find out from a can how many milliliters are in a can of soda?
It said for a 12 fluid ounce soda, 355 milliliters.
355, correct. And it turns out that a milliliter, 1 milliliter, is equal to a cubic centimeter, which is 1 centimeter to the 3rd power. So what went wrong with our calculation? Well, I blame the meter stick. We're in the right ballpark, but it's definitely bigger than we thought it was going to be. Or the real thing is smaller than we predicted. Okay. So that, I think, takes care of, and again, not that you're totally set, but that you maybe got a presentation, a video you can come back to regarding those kinds of conversions.